Hi guys, welcome to day 5. Over the last few days, we built standard RAG pipelines. Standard RAG is great starting point, but it has fatal flaws. It is fundamentally blind to the bigger picture. Today we are going to look at the exact architecture Microsoft and rest of the industry are pivoting to. In order to fix this, we are going to discuss about RAG graphs today. To understand why RAG graphs exist, you have to look at the main bottleneck of the standard vector search. It is strictly a local search. If you ask a highly specific question, it finds the exact text chunk flawlessly using nearest neighbors math. But if you ask a global question, like what are the overachieving themes across the entire dataset, the system panics. It just receives the top 5 most similar chunks and completely missing the dataset wide context. It sees individual trees, but it is entirely blind to the forest. So basically, rags are good to find like little bit or like particular minute details about a vector dataset. But if we need a holistic view of the entire things, so that's where rag graphs comes into play. Knowledge graphs. To solve this, we have to stop slicing text into blind chunks. Instead, RAG graph uses an LLM to read the data and extract its structure reality into a knowledge graph. We map our entities and nodes. These are your nouns like people, location, or company. Then we map the relationship between them as edges. The verbs, we transform raw text into an isolated string into an interconnected mathematical or spider web. So till now we have collected the entities and the relationships from our database. So what happens next is to search the web we just created, we use graph clustering algorithms. We group highly connected nodes together into communities. Just like all the mathematical stuff would be put under one community math, all the finance related stuff would be categorized into one community under finance. And like this, all the communities are formed. Then what we will do is we will compute the summary of each community and save them. So when a user asks a massive global question, the system doesn't search raw text. It runs a map reduce operation on all the communities that we have already pre-calculated, or through all the things operation across all the community summaries that we have pre-calculated and stored to generate a holistic intelligent answer. This architecture shift is exactly why we engineered the project Veritas. Standard semantic similarity wasn't enough to reason over the complex datasets we were working with. We built a GraphRAG engine to actually map relationships and synthesize global context rather than just retrieving dumb text chunks. So this is the architecture diagram. Notice how the architecture is fundamentally split. Phase 1 and phase 2 on the right are the asynchronous backend. This happens before the user ever asks a question. We ingest raw data, but instead of just dumping it into a vector database, we pass it through an LLM to extract the nodes and edges, building a literal knowledge tree. So this is the raw data set. It then go to the semantic chunker, and then it is passed on to the LLM entity extractor. So then it gets converted into nodes and edges, and a knowledge graph is formed. So by the help of this Leidens algorithm, then all the communities are formed and the LLM makes summaries for all these communities. So you can see these semantic chunkers take the raw text and put it into an embeddings model, which then it is stored in a vector database. This vector database is then applied into our phase 3 for vector search. And the summaries we got from the LLM are sent into MapReduce and then context synthesizer. Phase 3 is the real-time response engine. When a user drops a complex query, it doesn't just blindly search. It hits the intent router. The system dynamically decides, is this a specific logic query or a massive global query? As you can see, here is the intent router. So it decides if it is a local query or it is a global query. So if it is a global query, so then the outputs we got from the whole knowledge graph, Leiden's algorithm, graph communities, LLM summaries, then it is mapped with our global query. If it's local, it routes down to standard vector search. If it is a global, it routes to MapReduce engine, injecting all those pre-computed graph summaries we build in phase 2. Finally, it synthesizes the context into one holistic answer. This is how you build an AI that doesn't just retrieve text, but actually understands the dataset. Basic RAG is dead, GraphRAG is the standard. Now we will meet on day 6.